Welcome to Manasi Solutions. Today we are going to discuss about the zero divisors in ZN. What are the zero divisors in a ring? Consider a commutative ring R, then a non-zero number A in R is said to be zero divisor in R if there exists a non-zero number B in R such that A be equal to 0. Then we say that A is a zero divisor in R. Now we need to find what are the zero divisors in ZN. I am going to prove that the zero divisors in R are the numbers, in R, not in ZN. In ZN are the numbers in ZN which are not relatively prime to n. When we say that two numbers are relatively prime, two integers m and l, two positive integers m and l are said to be relatively prime if the GCD of m and l is equal to 1. If two numbers are not relatively prime, then the GCD of ml will be greater than 1. Okay, so we need to prove the elements m in Zn with the GCD of mn equal to d, which is greater than 1, are the zero divisors. The zero divisors in Zn. Now consider such an element m with the GCD of mn equal to d, which is greater than 1. Then consider m by d. Here GCD of mn equal to d, which means d divides m and n both. So m by d will be a integer. Now m by d multiplication modulo n, which will be equal to 0. Now m multiplication modulo n by d. We can change the position of d from first to second, and which is also equal to 0. And here n by d will be an element in Z. So if we denote n by d by L, then m multiplication modulo n, L, will be equal to 0, and L belongs to Zn, and which is a non-zero number. So we can say that what? M is a zero divisor in Zn. Okay, so those numbers which are not relatively prime to n are the zero divisors in n. And in reverse, if an element m is a zero divisor in Zn, then we know that m multiplication modulo n L is equal to 0 for some non-zero number L, and which implies n divides m into L. Therefore, the GCD of nm is not equal to 1, which means m and n are not relatively prime. So we can say that these are the only zero divisors in Zn. How we can calculate the number of zero divisors in Zn? We just proved that the zero divisors in Zn are those numbers which are not relatively prime to n. So the set of or zero divisors in Zn are equal to Zn minus, at first we know that a zero divisor in Zn is a non-zero number. So we need to remove 0 from Zn. And next we need to remove what? We know zero divisors are those numbers which are relatively prime to n. So any number which are relatively prime to n will not be a zero divisor. So we need to remove the elements in u of n also. And u of n contains the elements which are less than n and relatively prime to n. So the zero divisors in Zn is equal to Zn minus at 0 minus u of n. So the cardinality, so the number of zero divisors in this ring Zn is equal to what? How many numbers are there in Zn? There are n number of elements in Zn minus 1. Set 0 is a singleton set. So minus 1 minus how many numbers are there in u of n? U of n contains those numbers which are less than n and relatively prime to n. And we know that this is phi of n. So phi of n. Hence, the number of zero divisors in Zn is equal to n minus 1 minus phi of n. Okay.